horizontal. You can also have a problem like this. I have a mechanism now where I draw this line diagram. This is point A hinged, and this is point B, and this AB is a rigid link, and similarly I have BC. This is point C. So BC is another rigid link, where at this end I have a roller. And this is acted upon by a couple of 10 kilonewton meter. The dimension of this now, or this orientation given by this. So this distance A to B, this distance is 300, and from here to here, this distance is 600 mm consider. And this elevation of B from this horizontal position is given by 400 mm. Right? So this two bar mechanism shown in this figure is subjected to a couple moment 10 kilonewton meter at point A. Calculate the force P required. Now, where is force P comes? See, this is rotating this link AB, and BC is now going to have a motion, and that pushes this point C horizontally as there is a roller. So I require here a force P, which is horizontal direction, acting at this point in order to maintain this configuration dictated by these distances 300 mm, 600 mm, and this height 400 mm. If the distance, the height is varying, it is obviously going to vary. If this is rotating, this height is going to be reducing. When AB, BC is going to be horizontal. Then again, further it is rotating, then point B would be moving up. So like that, it will be changing. But now you are expected to solve this problem for this particular configuration given. That configuration describe the orientation of this AB and BC to the horizontal. So this angle is now, let's say, counterclockwise measured theta A, and this angle now here measured in counterclockwise sense theta C. Right? So now how do you solve this using virtual work method? That's the question. How do you solve this problem by virtual work method? Yeah. Your end there is no signal, I think. I'm not able to speak. Vivekananda Reddy.
Yes, sir.
What happened?
Yes, sir.
There's full noisy. You have any doubt? You ask, otherwise mute yourself. Do you
Yes,
have a
sir.
doubt?
No, sir.
No? You follow this virtual method, there will be a question in the examination. Okay? So you can mute yourself if you do not have a doubt. Okay. So now, how do you go about solving this? Is again it's simple to write a virtual equation, which is saying that summation of delta U equals 0. So I have here an active couple clockwise from minus 10 kilonewton meter. So I will substitute in kilonewton itself so that I'll get the load in kilonewton. So 10 kilonewton into delta theta A. So this angular position theta A would have an arbitrary angular displacement delta theta. That's what I write. So this couple into this is what is the work done by this application of this external couple. And this force P is to the left, so minus P into delta XC, because this point is C and it's horizontal delta XC. So this is equal to 0. So writing this is first step. In this, my task is to find delta theta A and delta XC, right? And I have to substitute them here. So how do I go about doing that? Right, so let's understand here what would be these angles here to solve this. So what is theta A because of this dimension? theta A would be, now let's complete this triangle for that purpose. So 300 and this height is 400. So that would be tan inverse of opposite 400 by 300. So it is tan inverse of 4 by 3. So that would be equal to 53.13 degrees. That's this given orientation at this static position. So for this application of 10 kilonewton meter couple, what is the magnitude P you have to find by this procedure? And now what is the length of this link? Because of this is given now clear. So the length AB, the difference between the previous problem and this problem is the link length AB and BC are not the same. So what would happen if I have a change in this angular position, delta theta A, there will be a corresponding change here, delta theta C. They are not same because of these lengths are different. In the previous problem, since the length are same, that forms an isosceles triangular formation. Whatever the change in this angular position, similar magnitude is this side also. Now that changes. So you have to establish that relationship between that change, right? So how do you do that? So for that, I have to find out now what is this actual length of this link. So what is the actual length of the link AB? That would be now by Pythagoras theorem itself I can find that would be 300 square plus 400 square. That would be equal to 721.1 mm. Similarly, what is now BC? So BC would be 600 square plus 400 square. That would be equal to, sorry, here it's 300 square plus 400 square is what is equal to 500 mm. Just do this correction. This is 500 mm. And here it is 721.1 mm. Right? And what is this angle now? This angle is, if I know this angle, say this is theta, it is 180 minus theta. So theta C is 180 minus theta C is 180 minus theta. So how much is that angle now here? Tan inverse of 180 minus tan inverse of 400 by 600. That's going to be 180 minus so that value comes out to be this angular value that's going to be, I have here found out 146.31 degrees. So now this obtuse angle, the orientation of link BC from horizontal measured counterclockwise and theta C is given by this. So now for these two angular position or of this link length, now what is the value of P is what I have to find out for the given couple moment. So next step is what I have written my virtual work equation. Next step is to find out these virtual displacements, delta theta A and this. So how do I do that? For that I have to write my expression of this. So theta A measured here, this orientation is counterclockwise. So angular position is theta A. Let me use that same table method, right? This is easier. So table method, what is that you write? Active force or couple. Active force or couple in the system. Position, coordinate, then virtual displacement. Virtual displacement. So here it's clockwise couple, so that's minus 10 kilonewton meter, and the position coordinate here is theta A positive, and its differential delta theta A. This is a virtual displacement. And here, this is for minus P active force, and the coordinate is XC. So what is XC now? How do I write XC? That would be AB cos theta A, AB cos theta A plus BC cos theta, or in terms of this, if I write the cos of obtuse angle is minus, so I should write here, this is minus BC cos theta C. Look at here, this minus sign, very, very important. Look at that, why is it minus sign, right? Why is it minus sign? Because cos theta C is, as per this, is an obtuse angle. So cos of angle greater than 90 is minus value, minus of minus become plus. So I will get this distance, this coordinate. So this is my XC coordinate. So what is my virtual displacement? That would be delta XC, which will be AB sine theta A into delta theta A minus BC sine theta C delta theta C, right? So here you see I have delta theta A and delta theta C. This relationship is what I have to find out, right? So that I would have in this expression only one. So here in this I have delta theta A first term, and the second term also I wanted this. So I will get delta theta C is how much of delta theta A, and I replace this delta theta C by that. This is delta theta C by that. So how do I do that? For that, let me have here a point defined D. So this BD vertical distance can be expressed in terms of both coordinate, right? I can write this BD by AB sine theta A, or that would be same as BC sine theta C, right? So if I have that, I can now get my delta theta A this by differentiating on both sides. So that's going to be AB differentiating both sides with that angle, respective angle. So AB cos theta A delta theta A, and this side it's BC sine theta C delta theta C. So what do I want is delta theta A and this relationship. So let me substitute the value of AB is 500 cos theta A delta theta A. This side it is 721.1 sine. Well, this is cos again, right? This is also cos. Cos theta C delta theta C. So delta theta C would be delta theta A. Okay, let me have this delta theta A would be equal to 721.1 cos theta C is 146.31 divided by 500 cos theta A, so cos 53.13 into delta theta C. So this value is going to be, so since it is cos of angle more than 90 minus, it's minus 2 times delta theta C, delta theta A. So I have this relationship established, right? So now I can substitute in this equation. So I can replace delta theta A by this and this, or delta theta C is 0.5 times delta theta A, and I will have one common term which cannot be equal to 0, and I can get for P. So putting this virtual displacement into this equation 1 now, I would be able to solve this problem, right? So minus 10 into delta theta A minus P into delta XE. So delta XE is now 500 sine theta A into delta theta A minus BC is 721.1 sine theta C into delta theta C. This delta theta C is what I will replace by minus 0.5 delta theta A. That's equal to 0. So now look at this minus and minus become plus, and these two terms are minus. That ensures the consistency of the work done. Consistency of the work done. How do you ensure? How do you understand that? Again, you look at here. In case if I assume that this couple creates virtual displacement, angular displacement in the same direction, then this P would do a negative one, right? Vice versa. So that is ensured now in this. That consistency ensured now in this.
Hello, sir.
Yeah.
Hello, sir. Sir, I have class at 3. Can I leave, sir?
Yeah, you can always.
Thank you, sir.
Later on, you can see this. Yeah. So now solving this further in a minute, I will complete. Anyone has got a class can leave now, and later on you can look at it. So now this value of P by solving I would get, right? So this P value would be, this is minus, so that goes on the other side. So delta theta A cannot be 0. So I have now this 10 goes on that side, so that's 10 divided by, and this term is positive. So I would have here doing correct delta theta A, yeah. These two should be I should substitute that in this, right? So here I require P now. So this is negative minus P into this all term, right? Into this all. So this become plus, yeah, this 10 by 0.5.
Sir, it should be minus 10.
Minus 10.
Yes, sir, because if you take P to the right side, then you take the denominator, then it should be minus 10.
Yeah. That minus and minus should go here just a minute. So here, if I take this on this side, see, let us write here itself, looking at this. Before substituting, I should have written that, right? So P would be from this equation, P would be minus 10 delta theta A divided by delta X, right? So this is that. So in this I should substitute now. So if I do that, P would be into delta theta A here divided by delta XC. Delta XC is this. What is that I substituted here? 500 sine theta A into delta theta A. This is also plus. So 500 sine 53.13, 53.13. Yeah, 53.13. I just see that it's going to be a positive value. I should get P value positive, right? 500 sine 53.13. Delta theta A is common, let me take it out. And this becomes plus 721. Sine theta C is 146.31. 146.31. See here I made one mistake. Look at here. XC is AB cos theta A minus BC cos theta C. So when I differentiate this, that would be, yeah, cos differential, this is correct. This minus sign would be here. So when I substitute this minus goes off. So this is plus 146.31. Correct. Into this into this I should substitute, right? So this value here, delta theta C is now 0.5. It's already.
Sir, in the differentiation, shouldn't the first term also be minus because the first term was also cos?
I don't know. No, differential of cos theta is sin theta, right? Minus sin theta. Okay, okay.
Sir, so it should be minus AB sin theta, right?
Yeah,
Sin.
correct. Yeah, here this term also is minus, right? This is minus and this is plus. See, this is all because of, yeah. So when I differentiate this AB cos theta A is minus here, I forgot this. This should be minus AB sin theta A del theta A. And here it is minus of minus become plus. Is that correct? This is what you are saying, right?
Yes, sir.
Yeah. So if this is minus and this plus, here I would have this term is minus and this term would be plus into this. So this minus of minus become plus. So here I would have one minus sign and this minus, and that will be taken out. Minus, and this is that now. So this minus minus goes off. I get the positive value of P. Yeah. This we have to do very carefully. See, this small mistake here made is finally we get the plus minus problem. So this minus minus goes and delta theta A is out here. So that goes off. I get now P value equals to 16.67 kilometer. Solving this. So what is that important here is while writing the coordinate, you have to write it carefully. So that's written here carefully. I have taken here minus side. When I differentiate, I forgot this. So this is minus AB sine theta A delta theta A. And here again cos theta minus of minus become plus here. So then we established here the relationship between that. There's a negative sign here. By substituting, this all comes out to be correct. So this is how you can solve virtual principal problem. We will solve another couple of problem on this Wednesday class, and that's all sufficient for this topic. And then we have next week no classes, and again when you resume back, we will have around 6 periods then on. So whatever that I'm going to teach, all are important for exam, and we'll try to justify completing the syllabus, right? So with that note, let me stop today's class. And if you have any doubts in today's class, you can ask, otherwise we'll stop. Download your attendance. Stop recording.